Welcome to the world of natural language processing, or NLP. NLP is a fascinating subfield of artificial intelligence that focuses on enabling computers to understand and process human languages. Imagine being able to talk to your computer or phone and it understands you just like another person would. That's the magic of NLP. In this video, we'll explore how NLP works, its real-world applications, and the challenges it faces. Whether you're curious about chatbots, language translation, or how your emails get filtered, NLP is at the core. Let's dive in and see how machines are learning to communicate with us in our own language. NLP is all around us, often in ways we don't even notice. Every time you ask Siri or Alexa a question, or when you type a message and your phone suggests the next word, NLP is at work. It helps businesses analyze customer feedback, powers translation apps, and even filters spam emails. The ability of machines to read, interpret, and respond to human language is transforming how we interact with technology. As we move forward, NLP will continue to shape our digital experiences, making them more intuitive and responsive. NLP can be divided into several categories based on its functions and applications. Some focus on understanding the structure of language, like syntax and grammar, while others interpret meaning and context. There are also categories dedicated to generating language, such as chatbots and text summarization tools. By breaking down language into manageable parts, NLP systems can tackle complex tasks, from translating documents to analyzing social media sentiment. Understanding these categories helps us appreciate the depth and versatility of NLP technology. The process of NLP is typically divided into several phases or levels. These include lexical analysis, syntactic analysis, semantic analysis, discourse integration, and pragmatic analysis. Each phase addresses a specific aspect of language, from identifying words and their forms to understanding the overall meaning and context. By moving through these phases, NLP systems can transform raw text into structured data that computers can work with, paving the way for more advanced applications like chatbots and sentiment analysis. One of the most visible applications of NLP is the chatbot. Chatbots are computer programs designed to simulate conversation with human users. They can answer questions, provide recommendations, and even help you shop online. There are two main types of chatbots: script-based bots, which follow predefined rules, and smart bots, which use AI to learn and adapt. As chatbots become more sophisticated, they're finding their way into customer service, healthcare, and even education. Let's break down the difference between script bots and smart bots. Script bots are straightforward. They follow a set of programmed rules and respond to specific commands. They're easy to build and integrate but have limited functionality. Smart bots, on the other hand, use machine learning and large datasets to understand and respond to a wider range of inputs. They can learn from interactions and improve over time, making them much more flexible and powerful. Both types have their place, depending on the complexity of the task. Humans and computers process language very differently. Humans use complex rules, context, and intuition to interpret meaning. Our brains can handle ambiguity, slang, and even sarcasm. Computers, however, rely on numerical data and strict syntax. Even a small error can cause a computer to misinterpret or reject a message. NLP bridges this gap by teaching computers to process language more like humans do, but it's a challenging task due to the nuances and variability of human communication. Arrangement of words in a sentence, known as syntax, plays a crucial role in communication. For humans, understanding the meaning behind a sentence often comes naturally, even if the structure isn't perfect. For computers, however, syntax is everything. NLP uses techniques like part-of-speech tagging to help machines identify the roles of words in a sentence. This is just the first step. Understanding the true meaning or semantics is much more complex and requires context. Words can have multiple meanings depending on the context. For example, the word red can describe embarrassment, anger, or a physical reaction. Humans use experience and intuition to interpret these meanings, but computers need explicit instructions. NLP systems must analyze the surrounding words and the overall context to determine the correct interpretation. This is one of the biggest challenges in natural language understanding, and a key area of ongoing research. Sometimes a sentence can have perfect grammar but make no sense. For example, colorless green ideas sleep furiously. Grammatically it's correct, but semantically it's meaningless. Humans can spot this easily, but computers may not. NLP systems must go beyond syntax and analyze semantics to truly understand language. This highlights the importance of combining both structure and meaning in language processing. NLP faces many challenges. Human language is full of ambiguities, slang, and regional variations. People make spelling mistakes, use sarcasm, and often speak in incomplete sentences. Computers have to deal with all these complexities. Development time is another factor. Building systems that can handle the richness of human language is a huge task. Despite these challenges, NLP continues to advance, making our interactions with technology more natural every day. Ambiguity is a major hurdle for NLP. Lexical ambiguity occurs when a word has multiple meanings. Semantic ambiguity arises when a sentence can be interpreted in different ways. Syntactic ambiguity happens when the structure of a sentence allows for more than one interpretation. Humans use context to resolve these ambiguities, but for computers it's a significant challenge. NLP systems must be trained to recognize and handle these different types of ambiguity. Humans can easily understand sentences with spelling mistakes or sarcasm, but computers struggle. NLP algorithms can identify common spelling errors, but unusual mistakes may still cause confusion. Sarcasm is even trickier. Words may have positive or negative meanings depending on how they're used. Detecting sarcasm requires understanding not just the words, but the intent behind them, which is a complex task for machines. Localisms and slang add another layer of complexity to NLP. These informal expressions often don't have dictionary definitions and can vary widely by region. For example, the word cool can mean temperature or approval, depending on the context. NLP systems must be trained on diverse datasets to recognize and interpret these variations, making language processing even more challenging. Despite its challenges, NLP offers many advantages. It allows users to ask questions and get direct answers quickly, saving time and effort. NLP provides precise information, avoiding unnecessary details. It enables computers to communicate in human languages, making technology more accessible. As NLP continues to improve, it will help bridge the gap between humans and machines, making our interactions smoother and more efficient. NLP isn't perfect. Sometimes it fails to understand the context, leading to unpredictable results. It may require more input from users, such as additional keystrokes, to clarify meaning. These limitations highlight the ongoing need for research and development in NLP. As technology advances, we can expect these disadvantages to diminish, but for now, they remind us that human language is still a tough nut to crack for machine. One of the most popular applications of NLP is sentiment analysis. Also known as opinion mining, sentiment analysis interprets and classifies emotions in text as positive, negative, or neutral. Businesses use it to gauge customer opinions about products, brands, or services by analyzing reviews, social media posts, and feedback. This helps organizations respond to customer needs and improve their offering. Sentiment analysis is a powerful tool for understanding public perception in real time. See how sentiment analysis works. Imagine a company wants to know how customers feel about a new product. By analyzing online reviews and social media posts, NLP algorithms can determine whether the feedback is mostly positive, negative, or neutral. This information helps businesses make data-driven decisions, address concerns, and celebrate successes. Sentiment analysis is widely used in marketing, customer service, and even politics to gauge public opinion. Machine translation is another major application of NLP. It automatically converts text from one language to another, making information accessible across language barriers. Whether you're reading a foreign news article or chatting with someone overseas, machine translation helps bridge the gap. Popular tools like Google Translate use advanced NLP techniques to preserve the meaning of the original text while translating it accurately. Machine translation systems use NLP to analyze the structure and meaning of the source language, then generate equivalent text in the target language. Early systems relied on simple word-for-word translation, but modern approaches use deep learning and large datasets to produce more natural and accurate results. This technology is essential for international business, travel, and cross-cultural communication. Text classification is the process of assigning predefined categories to documents. It helps organize large volumes of information, making it easier to find what you need. A common example is spam filtering in email, where messages are classified as spam or not spam. Text classification is also used in news categorization, sentiment analysis, and topic detection, making it a fundamental tool in NLP. Chatbots are everywhere, from customer service to virtual assistants like Siri and Alexa. They use NLP to understand your questions and provide helpful responses. Some chatbots are simple, following scripts, while others use AI to learn and adapt. As technology advances, chatbots are becoming more human-like, capable of handling complex conversations and tasks. Virtual assistants like Google Assistant, Siri, and Alexa have become part of our daily lives. They can set reminders, send messages, make calls, and even control smart home devices. By using speech recognition and NLP, these assistants can understand spoken language and respond appropriately. They're constantly improving, making our lives easier and more connected. There are two main types of chatbots: script bots and smart bots. Script bots follow predefined rules and are easy to build, but they have limited functionality. Smart bots use AI and large datasets to understand and respond to a wider range of inputs. They can learn from interactions and improve over time, making them more flexible and powerful. Both types play important roles in different applications. Script bots are designed to handle specific tasks using a set of programmed rules. They're easy to create and integrate into messaging platforms. However, their functionality is limited. They can only respond to commands they've been programmed to recognize. Script bots are ideal for simple tasks like answering FAQs or guiding users through basic processes. Smart bots use artificial intelligence and access to large databases to provide more flexible and powerful interactions. They can learn from user input, adapt to new situations, and handle more complex tasks. Smart bots are used in advanced customer service, healthcare, and even education, offering a more personalized experience. Humans process language using a combination of hearing, memory, and context. When someone speaks, the sound travels to the listener's brain, where it's interpreted and understood. If the meaning isn't clear, the listener asks for clarification. This process is natural for us, but teaching a computer to do the same requires sophisticated algorithms and lots of data. Computers process language as numbers. Every word, letter, and symbol must be converted into numerical data. Unlike humans, computers are strict. One small error can cause a message to be rejected. NLP helps computers interpret and process human language, but it's a complex task that requires careful programming and lots of training data. Make sense of human language, NLP systems must process and clean the data. The first step is text normalization, which simplifies the text and reduces its complexity. This involves several substeps, including sentence segmentation, tokenization, removing stop words, and more. By breaking down the text, NLP systems can focus on the most meaningful parts, making analysis more accurate. Text normalization is a multi-step process. It starts with sentence segmentation, dividing the corpus into individual sentences. Next comes tokenization, where each sentence is split into words, numbers, or special characters called tokens. Then stop words, special characters, and numbers are removed to focus on meaningful words. Finally, the text is converted to a common case, usually lowercase, to avoid confusion between words like apple and apple. Sentence segmentation divides a large body of text or corpus into individual sentences. Each sentence is treated as a separate unit of data. This step is crucial because it allows NLP systems to analyze language at a manageable level, making further processing more efficient and accurate. After segmentation, each sentence is further divided into tokens. Tokens can be words, numbers, or special characters. Tokenization allows NLP systems to analyze each component of a sentence separately, making it easier to identify patterns and extract meaning from the text. Stopwords are common words like they, is, and that appear frequently but add little meaning to the text. Removing stopwords along with special characters and numbers helps NLP systems focus on the most important words. This step improves the accuracy of language analysis by reducing noise in the data. To avoid confusion between words like apple and apple, NLP systems convert all text to a common case, usually lowercase. This ensures that the same word is treated consistently regardless of how it's written. It's a simple but important step in text normalization. Stemming is the process of removing affixes from words to reduce them to their base form. For example, healed, healing, and healer all become heal. Stemming is fast but doesn't always produce meaningful words. It's useful for quickly reducing words to a common root, but sometimes the result isn't a real word. Lemmatization is similar to stemming but goes a step further. It removes affixes and ensures that the resulting word or lemma is meaningful. For example, studies become study. Lemmatization takes longer than stemming but produces more accurate results, making it valuable for tasks that require precise language understanding. While both stemming and lemmatization reduce words to their root forms, the key difference is that lemmatization always produces meaningful words. Stemming is faster but less accurate, sometimes resulting in non-words. Lemmatization is slower but ensures that the output is a valid word, making it better for applications that require precise language understanding. Bag of words is a model used to extract features from text for machine learning. It counts the occurrences of each word in a document, creating a vocabulary for the corpus. The order of words doesn't matter, only their frequency. This simple approach is powerful for many NLP tasks, including text classification and sentiment analysis. Let's walk through an example of bag of words. Suppose we have 3 documents. After text normalization, we list all unique words in the corpus. For each document, we count how many times each word appears. This creates a document vector, a row of numbers representing the frequency of each word. These vectors are used in machine learning algorithms to analyze and classify text. The bag of words process involves 4 main steps: text normalization, creating a dictionary of unique words, creating document vectors, and repeating for all documents. This systematic approach transforms raw text into structured data that can be used for further analysis and machine learning. Once the vocabulary is set, each document is represented as a vector. If a word from the vocabulary appears in the document, its value is incremented. If not, it remains 0. This table of vectors is the foundation for many NLP algorithms, making it possible to compare and classify documents based on their content. TF-IDF stands for Term Frequency Inverse Document Frequency. It's a technique used to evaluate the importance of a word in a document relative to the entire corpus. Words that appear frequently in one document but not in others are considered more important. TF-IDF helps highlight the most significant words for analysis. Term frequency, TF, measures how often a word appears in a document. It's calculated by counting the occurrences of the word in the document. High term frequency indicates that the word is important within that document, but it may not be significant across the entire corpus. Inverse document frequency, IDF, measures how unique a word is across all documents. If a word appears in many documents, its IDF is low, meaning it's less significant. If it appears in only a few documents, its IDF is high, making it more important. The combination of TF and IDF gives a balanced measure of a word's significance. TF-IDF value for a word is calculated by multiplying its term frequency by the logarithm of its inverse document frequency. This formula ensures that common words across all documents get lower scores, while unique and important words get higher scores. TF-IDF is widely used in document classification, topic modeling, and information retrieval.